Okay. This is about my 10th take. Alright, I'm going to really keep this short after I've made 2 long videos. Alright, we've got polar coordinates. Here I've got r comma theta, or in this case, 3 comma pi 6. But I want to make, here I'm making little things a little different. I want to get a different coordinate and still represent the same point. Okay? So, but here I want to make sure that I put, just be able to work within some constraints. Here I want you to give me another coordinate for the same point, but r has to be positive, and make theta between 2 and 4 pi. Okay? Well, I've got 3 pi 6. Basically, I've got 3 pi 6 right here. Here's pi 6. Here's 3. Well, I've got to keep r positive, and I need to be greater than 2 pi, so I have to do a full rotation. So that'll be pi 6 plus 12 pi 6. Puts me all the way around to, here's 11 pi 6, 12 pi 6, 13 pi 6. So 3, 13 pi 6 meets that criteria. Okay? The second one was r is negative, and I want theta between 0 and 2 pi. And here you'll see that, so here is our point. One thing you can do if you want to keep the same point, but have different coordinates in your polar coordinates, is just add half a rotation, add pi or add 180 degrees, and then make r negative. Okay? So that was, we wanted r to be negative. R had to be less than 0. That was part of our constraint. So we're just going to take pi 6, add pi, which would take me all the way to right here, which is 7 pi 6. So pi 6 plus, what's a full pi will be 6 over 6 pi, or 7 pi 6. But I need to shoot back this way. I don't want, positive r puts me here on theta. I want a negative r. So negative 3, 7 pi 6. So if you want the same point and you want to make your r negative, just add 180 degrees or a pi, and then make your r negative and go back. Okay, so that's negative 3, 7 pi 6 is the same as 3 pi 6. And finally, I want r positive, but I want theta negative, less than 0, but not less than negative 2 pi. So between 0 and negative 2 pi. But r has to be positive. So here, I basically am going to do what? I can't go a half. I got to go all the way around. So let's just subtract. I've got pi 6 minus a full rotation, 12 over 6. That's 2 pi, right? 12 over 6 is 2. Okay, what's 1 minus 12? Negative 11 pi 6. Okay, so we go all the way around, and we're going to keep r positive. So that's going to be 3 comma negative 11 pi 6. Okay, and that makes sense. Let's count our pi 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's in the negative direction. Okay, 3. So that's different. That's making different coordinates polar to get the same point with constraints. Negative r, and we're making theta be between certain elements, 2 pi to 4 pi and so on. All right? Something I'll go into more tomorrow, but if you want to just keep r theta and keep r the same positive, just take theta and add increments of theta to increments of 2 pi to theta. So if I want to get a different coordinate, I want to keep the same point but different coordinates. If I'm going to keep r positive, just take your theta and add, I've got 2k pi. Well, k is just any integer. So 2 times 1 is 2 pi. Make k2, 4 pi, 6 pi. Just doing full rotations, okay? All right? If you want to have the same point but make r negative, okay? R theta, make it a negative r. Take your theta, like pi 6, and they add pi. Just go half the way around, and now you're on that back side. You're on the back side here, but then make your r, so you added pi, and then you make your r negative, obviously, to get back to that point. But once you get that theta, now add increments of 2 pi to that. So if you make your r negative, take theta plus pi, and then once you get that, that will work, and then you can add increments of 2 pi to that. So we took pi 6, made it 7 pi 6 with a negative r, and we could add 12 6 pi to that, 19 6 pi, and so on. Okay? All right. Anytime your polar coordinates have an r of 0, I don't care what theta is. You can have any theta you want. It's still not moving from the pole. Okay? It's the origin. Okay? All right? So 0 and theta can be anything. It's the same point. Okay? I think you saw that on your worksheet. Okay? All right. I'm going to try to make this quick. You've got 6, 5 pi over 3. You know your radius is 6. You've got your angle. You can get your reference angle too. Okay? So let's, hopefully you can see this. Okay? There's your triangle I'm making. Okay? I want to go from polar. Let's solve for, I know this is pi thirds, right? I'm 5 pi thirds. I'm what? That's 60 degrees, reference angle. This is 300 degrees, okay? This is 1 pi thirds shy of 6 pi thirds, which is 2 pi, so that's pi thirds. So I know theta. I know theta. So if I want to solve for x, that's our standard. I've got adjacent and I've got the hypotenuse, or x and r. So that's cosine of 60 or theta. I'm just being generic here. In this case, it'd be pi thirds or 60 equals x over r. In this case, r is 6. Okay? All right? Multiply both sides by 6, or your cross product. I've got x equals r cosine of theta, or in this case, 6 cosine of pi thirds or 60 degrees. Okay? Now we'll solve for y. Just do one. You can only do one at a time. All right. Now we're dealing with what? We know theta, 60 degrees or pi thirds. Opposite over hypotenuse. That's sine. Sine of theta equals y over r, and r is 6. Multiply both sides by 6, or your cross product. Y equals 6 sine of 60 degrees or pi thirds, or y equals r sine theta. That's these two things here, very important. Okay, and fine. So they're very important. Get that. Finally, come on. I'm getting a lot of glare. Okay. I don't know why they opened that window up there. All right. Here's a point. On our Cartesian, we're going to go polar, x, y, to r, theta. I just draw my radius, and I make a triangle. We'll use Pythagorean theorem to solve for the radius. This is my x, this is my y, and this is a theta. So we know this is 3 and this is 6. We know our values for x and y, so we can solve for theta. Opposite and adjacent. It's always going to be tangent, okay? All right, we can use, if we figured out radius first, we could use sine and cosine too, but let's just find theta. And it's always going to be inverse. Tangent of theta is y over x, or opposite over adjacent. So inverse tangent of, in this case, 3 over 6, opposite over adjacent, equals our angle. Okay? And here I have tangent inverse of 3 over 6 is 26.56, 26.6. Okay, so that's 26.6. We use Pythagorean theorem. 6 squared, this is 6 here, and 3. 6 squared plus 3 squared is 45. 45 equals c squared, and we square root both sides. Remember, that's 9 times 5. 9 square root of 9 is 3, so I can rewrite that as 3 root 5. So our polar coordinates are 3 root 5 or the square root of 45 and 26.6 degrees. Okay? All right? So always make your triangle. Oh. Bad. What did I mess up on? That is a reference angle, right? That's 26.6 degrees, right? Okay? This was our angle right here. Sorry about this. I'm in a hurry to get this video done. This is my angle. So remember, reference angles, I kept everything positive on that. Notice I did 3 over 6. I just want a positive angle. I didn't use negative x or negative y. Because I just want that reference angle, which is what? A reference angle is this. The terminal side to the nearest x-axis. So I know this is 180 plus 26.6, okay? So I'm sorry, I caught myself. So 180, okay? So that's going to be 206 basically, or 207. So that is my polar angle. So I've got the radius, and we figured this out here. So yeah, when you solve for a reference angle, you might have, if it's quadrant 2, be 180 minus your reference angle. Quadrant 4 is 360 minus your reference angle, okay? So this would be 180 plus that 26.6, or, I'll make it 27. So 180 plus 27 is 200.7, okay? That's it. I can check the time here. All right, hope you got all that. Thanks.